We're inside a cosmic hole. Not empty, just fewer galaxies than average. Astronomy calls it a void, an underdense region in the cosmic web. But what is a web? Filaments of galaxies span the universe. Between them, broad gaps open. Our neighborhood sits in one. Popular images look crowded, stars shoulder to shoulder. Reality is sparser. Matter threads into filaments, knots, and wide, dark basins. Voids, vast volumes with density well below the cosmic mean. Filaments, bridges where galaxies and gas flow. Nodes, clusters and superclusters. The traffic circles of the web. Zoom to us. Local group, the Milky Way, Andromeda, and dwarfs. They drift along a filament's edge, with the local void yawning nearby. A low-density region shaping our motion. Beyond, Laniakea, our greater basin of flow. Its currents pull toward the Norma Centaurus region, while voids ease us outward. Underdense doesn't mean lifeless. Galaxies still form and shine. But statistics change. Fewer neighbors, longer distances. Dark energy stretches all. Structure carves the rest. Map the sky and the pattern appears. Redshift surveys reveal filaments, nodes, and yawning voids. We live inside one of those gaps, a quiet address in a laced universe. We live near a cosmic gap, the local void. Redshift surveys map distance, the stretch of light reveals depth. Plot the sky, and a web appears. Filaments, nodes, and vast hollows. The Milky Way sits on a wall, right beside that underdense region. Underdensities push, overdensities pull. Galaxies stream away from voids and toward mass. That flow helps define Laniakea, the basin of attraction we inhabit. At its heart, the Great Attractor, an overdense region. Opposite lies a dipole repeller, a deep underdensity guiding motion. Vectors point from the local void across our wall toward that mass. Multiple surveys trace it. Maps agree on the pattern. Redshift means distance, on average, as space itself expands. Peculiar velocity is the extra motion, what gravity adds to that expansion. Combine both, and local flows sharpen into streams. The local void stands out. Fewer galaxies per volume nearby. Denser walls host superclusters. Virgo, Perseus Pisces, threads of light. Laniakea links them. One gravitational basin, many streams. Our motion, about 600 kilometers per second, marks this dipole. Part points toward the Great Attractor, part away from the repeller. Emptiness pushes by lacking pull. The local void matters. Geometry and statistics agree. Independent reconstructions match. Names guide us. Local group, local void, Laniakea. Maps, not borders. In short, a wall beside a void, flowing toward greater mass. Next, the thermal rain and what survives. In the cosmic web, inside a hole means a void. Matter density below average, gravity weaker, expansion just a little faster. Galaxies feel that deficit as outward peculiar velocities, flowing from the void's center toward its walls. Add the Hubble flow and you see it. Net motion that carries galaxies away from underdense regions. At the boundaries, matter piles up, sheets and filaments, forming bright walls around the emptiness. Void interiors host few, faint, blue-tilted dwarfs. Edges guide traffic along filaments toward nodes. It's not a push, but the absence of pull. The dipole repeller. Underdensities that seem to drive flows away. Our local group drifts partly away from such a repeller and toward a mass concentration, the Shapley Attractor. Watch the field lines. Vectors stream outward from the void, then bend along filaments like rivers. As matter evacuates, the center rarefies and the edge thickens. Void growth by gentle, relentless flow. Shapes start near spherical, then merge. Sponge-like cavities stitched into the web. Convection-like towers are myths. Here, flows are quiet. Kilometers per second over megaparsecs. Near the walls, streams converge. Galaxies slow and settle, feeding clusters at the junctions. Inside the hole, the expansion wins. At the boundary, gravity reclaims the flow. Macro to micro. From a void's calm center, zoom to a textured wall. Dwarf smudges giving way to crowded light. Picture it as an expanding wireframe sphere embedded in a lattice, nudged by surrounding mass. Not empty, just underdense. Deep voids can reach contrast near -80%. Even light feels it. Weak lensing in reverse. Slight demagnification through the hollow. Map the flows, and repellers emerge where gravity is missing. Negative peaks in the velocity field. The dipole repeller is one such hollow. Its deficit helps set our motion through space. Together with the Shapley Attractor's pull, it helps explain our large 600 km/s drift relative to the CMB. Boundaries are where structure blooms. Walls brighten, nodes blaze, and streams become streets. Inside the hole, the script is simple. Less pull, faster local expansion, outward peculiar flow. Over billions of years, voids merge, the web sharpens. Islands of light cling to the edges. That's inside a hole. Underdensity, swift escape paths, and moving walls that bound the dark. Hold the map of flows. Next, we return to a planet reshaped by darkness. After the Big Bang, the young universe was almost smooth. Tiny temperature ripples in a sea of light. We read them today as the cosmic microwave background. Gravity began to amplify those ripples. Dark matter, feeling only gravity, gathered first, seeding the pattern to come. As space expanded, over-dense regions grew while under-dense regions emptied. Voids widened. Filaments began to take shape. Ordinary matter fell into dark matter wells, cooling, flowing, and settling along walls and nodes of the growing web. Over hundreds of millions of years, streams of gas followed the filaments, feeding knots where mass pooled. From initial noise to organized pattern, the web emerged in simulations, and in the sky we map. At the nodes, halos collapsed. Shocks and cooling sparked the first stars and galaxies. Filaments bridged the nodes, walls stretched between them. Around all of it, vast voids continued to expand. Most of space is empty. Matter traces a thin, luminous skeleton through the dark. Where threads cross, clusters grow, gravity stacking halos into cities of galaxies. Billions of years pass. Cosmic expansion continues. Gravity builds structure. Dark energy later slows new growth on the largest scales. Mergers sculpt halos. Feedback stirs the gas. The web refines its lines. Inside halos, disks and spheroids assemble. Stars forge elements, explode, and cycle matter back. Zoom out. A universal pattern. Voids, walls, filaments, and nodes woven across the cosmos. Our local group lies in a modest filament near a vast void. Typical, unremarkable, and real. We orbit an ordinary star in a typical spiral galaxy. Nothing central to the map. Just one node among many. From CMB ripples to a lattice of galaxies, statistics agree with theory. The pattern holds across the sky. No single step, rather a chain. Tiny density ripples, gravity and dark matter, cooling and feedback, web from simplicity. We map the web with galaxy surveys and weak lensing, light bent by mass revealing hidden structure. Simulations and data align on large scales. Details sharpen as instruments and models improve. The lesson is simple and grand. Small differences, long times, and gravity. Structure emerges. We are ordinary inhabitants of a sparse patch in a vast web, billions of years in the making. Fact 2. Structure matters. We live in walls and voids, and that can tilt what we measure. Type Ia supernovae are our standard candles. Their light curves and colors standardize distance. Calibrated by nearer anchors, Cepheids or TRGB, these explosions map expansion with precision. Plot brightness against redshift, and you read Hubble's law, an average rate at which space grows. But if we sit in a mild local void, under dense space, nearby galaxies stream outward faster, biasing H0 high. Coherent bulk flows add peculiar velocities on top of Hubble motion, speed that isn't expansion. Compare local shells to the wider universe, and you can see how density contrasts tilt measurements. Along the way, gravity lenses the light, magnifying some supernova, dimming others. Weak lensing adds scatter that averages out with numbers. So catalog size and sky coverage matter. Selection and dust play roles. Malmquist bias and reddening, corrected with careful photometry. A local void helps, but not enough. The deficit required to erase the Hubble tension is too large for surveys. Galaxy redshift maps and supernova sets, DESI 2M++ and Pantheon Plus, find only mild local underdensity. Distance ladders hinge on anchors, Cepheids and hosts, or TRGB and halos, each with different systematics. Crowding, metallicity, 0 points. Meticulous calibration trims small biases that move H0 by a little. Meanwhile, the CMB infers H0 from early universe physics, model-dependent yet precise. We map peculiar velocities with supernova, Tully-Fisher, and surface brightness fluctuations. Radio surveys and the kinetic Sunyaev-Zeldovich effect trace bulk flows on vast scales. Standard sirens, gravitational wave distances, promise an independent ruler to test both sides. Time delay lenses add leverage, multiple images clocking cosmic geometry. Wide, weak lensing maps weigh the line of sight, quantifying magnification biases to supernova distances. Simulations show the local void effect is real but modest. Corrections shift H0 by only a few percent. Precision comes from craft, stable instruments, cross-calibrated passbands, uniform pipelines. The story is subtle. Structure nudges light and motion. Never clickbait, always careful accounting. A mild void can explain a sliver of the gap. Intriguing, but not the whole answer. What matters is mapping. Bigger samples, better sky, many probes, letting evidence converge. Roman and Rubin will extend the map. Our mild void, our flows, our lenses, measured, not assumed. Our neighborhood sits inside a cavity, the local bubble, carved by ancient supernovae. About 1,000 light-years across, thin gas, warm walls of dust, and hot plasma. Young clusters sit on its rim, star-forming regions sparked along the shell. Inside, dust is swept back. Outside, denser clouds wait to collapse into new stars. The bubble is galactic, local, small on cosmic maps. Not a cosmic void. Voids between galaxies are far larger, tens of millions of light-years across. Our Milky Way belongs to the local group, dwarfs, Andromeda, and us bound together. The group rides a filament on the edge of an underdensity often called the local void. Filament flows pull toward Virgo. Nearer, the local sheet outlines our lane. Scale stacks, bubble in the disk in the halo, halo in the web. We map the bubble by starlight, dust reddening, absorption lines, precise distances. Gaia pins parallax, 3D dust maps trace the shell like a faint bruise in the disk. Supernova echoes linger, hot cavities merging, edges bright with newborn stars. Beyond, surveys stitch the web, galaxies threading filaments between yawning voids. DES mapped weak lensing. DESI charts redshifts by the millions. Euclid sketches cosmic geometry from space. Rubin will sweep the sky each night. Together they refine our maps. Near to far, bubble to web, evidence over awe. Timeline. Supernovae carve the bubble. Stars now form on its rim. Surveys chart the larger flow. Pattern. Structures nest. Local shells inside galactic arms inside the cosmic web. From these maps, context. A star-forming rim, a filament edge, a nearby underdensity. What endures observationally? DS, DSE, Euclid, and Rubin sharpening the picture night by night. After the fires, the sky cleared, and so did our view of where we live. Light returned, and with it, a question. What is our place in all this? We are not at the center. We orbit a star in a modest arm of a common galaxy. Our neighborhood is thin and dimmer than most, quiet lanes between brighter crowds. Astronomers call it a cosmic hole, a local underdensity where galaxies are sparse. Living in a low-traffic lane teaches humility and sharpens curiosity. We map from here outward, measuring, comparing, testing. Telescopes under dark skies trace stars, gas, and dust, our quiet corner to the rim. Distance is our compass, motion, our clock. We read redshifts in standard candles, small lights that fix great spans. We chart flows, how galaxies drift along the web's filaments. Filaments gather, voids relax. Our path is one current in a larger sea. The more we measure distances, the more tomorrow's sky becomes predictable. Motions reveal tides of gravity, subtle pulls that steer our long future. Clarity grows step by step, map by map. We find that quiet regions like ours are part of the pattern, not an exception. From local stars to the deep survey lines, the picture resolves. We are a small light between larger lights. That is enough to begin. Awe invites care. Perspective invites patience. We live inside structure, woven, not central. Predictability grows with every measured distance, every careful flow. And still, there is work. Steady, quiet, cumulative. Observatories keep watch, the data keeps coming. Each survey knits another thread in the map. Evidence first, then story. That is how we find our place. From parallax to standard candles to deep time baselines. The map expands. Our assumptions shrink. Galaxies drift on gentle arcs, crossing epochs we only sample. Patience is coded into the sky itself. Variety blooms where structure allows, on land, in sea, and between stars. In this thin, dimmer neighborhood, life learned to look up. Time is the medium, attention is our tool. Causes and consequences, traced by light, written in motion. We keep warmth by understanding where we are. The chapter begins with humility and continues with measurement. We read the past to forecast the path ahead. That we can do this at all is both astonishing and grounding. We are witnesses and stewards of a small light in a vast weave. Curiosity builds instruments. Care guides what we do with them. We read tomorrow in today's light. Models meet rock, spectra, and time. Evidence decides. Birth and death of stars. shifting continents, climates, and shields, context for home. Detectives of the cosmos, caretakers of a habitat still healing. This isn't only observed, it's lived. Wisdom is choosing to measure well, and to act with what we learn. Each discovery deepens awe and responsibility. Our task is grand and patient. Timescales dwarf us. Attention still matters. Feeling small can sharpen purpose. Beauty and truth travel with duty. Tonight, Earth's blue glow rests in a wider dark. Far beyond, stars forge and fade, quiet engines of change. Endings and beginnings frame our place and our task. Keep a light in the dark. Keep a record in the noise. Give meaning to our brief, habitable instant. For now, the stars still shine. Galaxies still drift on graceful arcs, and here we keep watch, learning, measuring, preparing. Tonight's light carries memory and direction. Our location, a faint lane between brighter filaments, home enough. Pull back, from our dot to the cluster to the web, order emerging with scale. What future moves you to act, so clarity guides our hardest days? Hold this warm, sunlit instant, measure it well. We live in a cosmic whole on a small light. Keep watching the sky.